Okay, let's take a look at problem number 7. This is a complicated question, lots of parts. Let's take it a little bit at a time. Let's start though with, let's think about this here. We've got QT is a perpendicular, this is a perpendicular bisector, which means this line right here, same distance away from this, these are equal distance, right? And so that means this equals this, so we could solve that. That'd be something we could solve. Okay, let's go ahead and solve it. I would subtract 2y from both sides. And since I'm getting rid of the 2y off of the right, I'm going to go ahead and get rid of this 31 off the left. Bring down my equal sign. And we go, okay, 5y minus 2y is 3y. That's gone. That's gone. This is 36. Divide both sides by 3 and we get y equals 12. So there's my y. Now let's go for the x here, because I noticed down here this is already labeled. This equals this, right? So since these are equal to each other, I can say this is equal to this, and I have a new equation to solve. 4x plus 4 equals 7x minus 17. And you might be thinking, well, what about this? Well, it's there. We'll deal with that, but let's just look at the things that we know, right? I know these are equal, so I can say these are equal and solve it. So let's go ahead and solve that. So I would get rid of the 4x from both sides, and since I'm getting rid of the 4 off the left, I'm going to get rid of the 17 off the right. And then let's do that math, right? Equals 4 minus, that's gone, 17, that'd be 21. 7 minus 4 is 3. Divide both sides by 3, and I get x equals 7. All right, so there's my x, there's my y. Now we have all of these other things to find. So let's figure out how do we find those, right? So let's just start by this first one, PQ. PQ, there's P, there's Q. So PQ is this one right here. PQ is 5y minus 31. Y would go right there. What is y? It is 12. 5 times 12 is 60. 60 minus 31 is 29. Now I could plug in a y for this, but I know these are equal, so this one would also equal 29. So QR, is that one? Yep, oh, it's the very next one. It is also 29. So I have this one, I have this one. Okay, let's see here, PS, where's P? There's P, there's S. PS is this one, so it needs an x. So PS equals 4 times x plus 4. What was my x? 7. 4 times 7 is 28, plus 4 is 32. So PS is 32, and then I know this one is equal to this one, so I could plug that 7 in there and work this out, but I know already it should equal 32, so I'm going to say SR 32, and that is the next one. Okay. Now let's see, the next one we have here is PT. PT is this one right here. Sorry about that bell ringing in the background. PT is right here. 6x minus 2y is PT. So notice it has the x and the y in it. So we would say PT equals 6 times x minus 2 times y. The x would go here. The y would go there. 6 times 7 is 42. 2 times 12 is 24, so 42 minus 24 is 18. So this one is 18. Now if this is 18, and this is a perpendicular bisector, that means this side would also be 18. It doesn't ask for that, but it does say PR. PR is this whole big long line. Well, if it's 18 here and 18 here, I could just do 18 plus 18 and get 36 for PR. And that is how you do complicated problem number 7.